always secure, and your streaming services never buffer. It represents a monumental leap forward in how we design, manage, and interact with the networks that have become the lifeblood of our modern world. As we move forward, the integration of AI in network management will continue to drive us towards a future where connectivity is seamless, reliable, and ever-present. Network engineering is often an unseen and underappreciated field. It operates behind the scenes, quietly ensuring that data flows seamlessly from one point to another. Yet, its importance cannot be overstated. Network engineers are the architects and caretakers of the complex digital highways that connect us all. They are responsible for building, maintaining, and optimizing the networks that power our homes, businesses, and critical infrastructure. The digital landscape is constantly evolving, becoming more intricate and demanding with each passing day. This relentless growth places an incredible strain on network engineers. They are tasked with managing increasingly complex networks, often with limited resources and under immense pressure to minimize downtime. The sheer volume of data, the rise of new technologies, and the constant threat of security breaches all contribute to a challenging and demanding work environment. Into this challenging landscape steps artificial intelligence, offering a transformative set of tools and capabilities. AI has the potential to revolutionize network engineering, automating tasks, providing predictive insights, and augmenting human capabilities in unprecedented ways. With AI, network engineers can shift from reactive problem-solving to proactive network management, anticipating issues before they arise, and ensuring smoother, more reliable network performance. Section 5. AI in Action: Predicting Failures, Optimizing Performance. One of the most impactful applications of AI in networking is predictive maintenance. This involves using advanced machine learning algorithms to analyze historical and real-time data from network devices. By doing so, AI can predict when a piece of equipment is likely to fail, allowing for timely maintenance and reducing the risk of unexpected downtime. By analyzing vast amounts of network data, AI algorithms can learn to identify patterns and anomalies that often precede network failure.